there are two sequences, there are two limit points. If I take, there are two sequences that lead to that. I can just take summation of elements sequence wise. Yeah, I can extend the sequence as that both of them are the same length, and I take the summation of the two. Then the summation of the two sequences will converge to the point that I am now looking at. So even if I take a sum of two limit points, it will again give you a limit point. Yeah, so that way you can prove that this set is closed under addition and subtraction. Then all the remaining stuff, your zero trajectory lies in this set, negative lies in this, all of them come through. Right? So you have similarly, you can also prove for scalar multiplication. If it's a limit point, you can take a sequence that leads there. Yeah, then each point in the interior, its scalar multiple also gives you a point in the interior. Therefore, when you take, you can define A into a limit point also as a limit point of these trajectories. So that way, so all of these things, by just taking limit points, you can prove that this is a vector space.
So by scaling the interior points, you are scaling the limit point also.
Yes, you do. Although you do not have a definition for a length at the limit point, but you can look at this point as a limit point of this. You can create another trajectory such that its limit point goes there. Right? So that way you can prove that this continues to remain a vector space. If it continues to remain a vector space, then you will have. So what is the basis for this vector space? E raised to j omega t is the basis for this vector space. Alternatively, you can take impulse at every point from 0 to infinity. That also forms the basis of that vector space. So when you take impulse at every point and you express a trajectory in that, you get the time domain expression. And when you take e raised to j omega t and you express it in that, you get frequency domain expression. Both of these are, the transformation between these two bases is an orthonormal transformation. That both of these happen to be orthonormal bases. Therefore, your length is preserved when you do that multiplication. Right? So that's roughly how you look at it. Right? Is that all right? Understood? So next class we will be having from 11 to 12:30 or 10:30 to 12? 11 to 12:30, right? Who's the maths guy? You are the maths guy. 11 to 12:30.